the fundamental theorem of calculus. We introduce the area function of f with the lower limit a, and is defined as a of x equals the integral from a to x f of t dt. It is a signed function from a to x. It is also known as the cumulative area function, or the area so far. It is a function who depends on x starting at a. It is in terms of x. For example, if f is a function whose graph is shown below, and a of x is the integral from a to x f of t dt, evaluate a of x when x is 0, 1, 2, 3, 4, 5. The graph is given. This is f of t. And so a of 0, by definition, is the integral from 0 to 0 of f of t dt. By looking at the graph, 0 to 0, the area is 0. A of 1 is the integral from 0 to 1 f of t dt, which is the area under the curve from 0 to 1. It is a triangle, so the area is 1/2 base times height, so the area is 1. A of 2, by the definition, is the integral from 0 to 2 f of t dt. But this is the integral from 0 to 1 and then 1 to 2. So the integral from 0 to 1 f of t dt plus the integral from 1 to 2 f of t dt. But the first integral is 1, and the second integral is the area of the rectangle, which is 2. A of 3 is the integral from 0 to 3 f of t dt, which is the integral from 0 to 2 f of t dt plus the integral from 2 to 3 f of t dt. Remember, by the definition, it is the area so far. The first integral is a of 2, and the second integral is the signed area under the curve above the x-axis, and we estimate that it is about 8.3, and so a of 3 is 4.3. A of 4 is the integral from 0 to 4 f of t dt, and we can split it into two integrals, from 0 to 3 and from 3 to 4, the integral of f of t dt. But the first integral from 0 to 3 is a of 3, and the second integral is the signed area between the x-axis and the curve. Since it lies below the x-axis, its signed area is negative, and so a of 4 is 3. A of 5 is the integral from 0 to 5 f of t dt, which can be rewritten as the integral from 0 to 4 f of t dt plus the integral from 4 to 5 f of t dt, but the first integral is a of 4, and the second integral is still below the x-axis, so it is minus 1.3, and so a of 5 is 1.7 roughly. Thus we see that if a of x is defined to be the integral from 0 to x f of t dt, then when x is 0, a is 0, when x equals 1, a is 1, when x equals 2, a is 3, a of 3 is 4.3, a of 4 is 3, and a of 5 is 1.7. If we plot these points on the xa axis, 0, 1, 3, 4.3, 3, 1.7 at the y values, or the area, and assuming that this function is continuous, we draw a smooth curve through these points. Observe that the area function is increasing from 0 to 3, corresponding to f of t being above the x-axis from 0 to 3, and is decreasing from 3 to 5. And so a is an antiderivative of f of x, that is, a prime of x equals f of x.